Kau tolong bilang cintakah tidak, kau cintakah tidak, jangan sampai dukun bertindak. Tinggal jawab mau tak tidak, oh mau tak tidak, yang sampai tak tidak. Jangan dicurahkan, jangan bila selalu saja kau dimana aku dapat. Adikku bagus ini kan, sumpah sama unika, jadi pusing pusing karena setua. Aman saja mau ngapain mau repot, jangan sampai tua turun dari foto. Honeymoon di Inggris, di Paris, di Jerman, pasti kau bisa barang jalan aman.
Assalamualaikum and a very good day. My name is Fatin Nurul Nabila binti Latif, metric number J23A0538.
My name is Nur Husna binti Ahmad Syabril. My metric number is J23A0717.
My name is Nur Najiha binti Muhammad Saif. My metric number J23A0523.
My name is Nur Aisyah Nabila binti Rahman. My metric number J23A0560.
Today, we are going to do a pre-felling inventory in a forest setting, which means that we have to take every condition and information about the tree in the plot that we are taking before a big commercial felling.
That we use throughout this pre-felling session. First of all, a measuring tape, a compass, a clinometer, a red warning tape, and a machete. For the measuring tape, this one was made from a fiberglass and it measures in centimeter, inch, feet, and meter. In this case, we are using meter to know the distance between points and centimeter to know the tree height and circumference. This is the starting point of the measuring tape. How to use the measuring tape? Just unroll the measuring tape to the distance that we want, then mark the point. First of all, we start the pre-felling inventory session by finding the most suitable starting point for our 10 meter by 10 meter plot.
Before we step into the forest, we select a starting point at the entry. We use the compass to find the true bearing of the forest road. Why? This road bearing is crucial because our inventory line, the main path for our plots, must be plotted parallel to the forest road. This gives us a consistent sampling pattern. We lock that bearing into the compass. That's our marching order. Now, we find a spot inside the forest to begin plotting the biggest square, 10 meter by 10 meter. We use the measuring tape and carefully measure exactly 10 meters along that bearing. Corner 2 is marked with another stake. That's one side done. Now we need a perfect square. From the second corner, we use the compass to find the bearing at the angle to our first line, a perfect 90-degree angle. We measure another 10 meters along this new line. Finally, from the third corner, we measure back 10 meters along the original parallel inventory bearing. We mark the final corner, and just like that, we have our accurately plotted 10 meter by 10 meters. We mark the first corner with a wooden stake and some tape. This is our anchor point. From this corner, we point the compass exactly to the true bearing we recorded from the road. This is the first line of our plot.
Next, we move on to establishing the smaller subplot, the 5 by 5 meter and the 2 by 2 meter plot, which are nested within the main subplot. Using the same tool bearing as the main inventory line, we first measure 5 meter from the designated starting point to form the first side of the 5 by 5 meter subplot. At that point, we turn 90 degrees and measuring another 5 meter to form the next side, placing wooden stake at each corner until the square is complete. We then repeat the same process to establish the 2 by 2 meter subplot by measuring 2 meter along the inventory line, turning 90 degrees and completing the square with the measurement. Afterward, we began collecting all the required data from each subplot, carefully recording every detail needed for the pre-felling inventory. In the 10 by 10 meter subplot, we record the number of major trees, Their species, if identified, their circumference and their diameter at breast height. In the 5 by 5 meter subplot, we collect similar information for smaller trees, capturing important detail about younger or less developed individuals. Meanwhile, in the 2 by 2 meter subplot, our focus shifts to sapling, where we record the number of saplings, their species if known, and their height. Collecting this measurement allows us to evaluate tree density, forest structure, and the level of regeneration within the forest. This information is essential for understanding the overall condition of the forest and for planning sustainable logging operation, ensuring that any felling activities do not compromise the health and continuity of the forest ecosystem.
For this task, I selected one tree within the 10 meter by 10 meter subplot. This is the tree I used to measure and calculate its height. Measuring the distance D. The first step was to measure the horizontal distance between myself and the base of the tree. This distance is called D and is an important value for the height calculation. Measuring the angle A. I used a clinometer to measure the angle toward the top of the tree. This angle A represents the slope from where I am standing to the tree height point. Flat ground formula. Since this area is flat ground, I use the basic formula H equals 10 A times D, and if your height need be included, the formula becomes H equals 10 A times D plus here. You can display the formula on the screen here. Simple calculation. After obtaining both the distance and the angle, I insert the value into the formula. From that calculation, I was able to estimate the actual height of the tree. For the tree, I selected within the 10 meter by 10 meter subplot. I recorded to main value the angle A, which is 55 degree, and the horizontal distance D, which is 8.16 meter. Since this area is flat ground, I use the basic formula H equals 10 times D plus year height. I began by feeding the value of 10, 55 degree, which is approximately 1.4281 meter. Then I multiply this value by the distance of 8.16 meter. For this calculation, I obtained an estimate height of 1.652 meter. Finally, I add my ear height, which is 1.5 meter. So that estimate total height of the tree is about 13.152 meter. And that is how the tree height was calculated using the flat ground formula. And that is how I measure a single tree in the subplot using the flat ground height calculation method. It is a simple process, but it plays an important role in forest assessment. I hope this explanation is helpful.
And this is all from us, from group 17. Goodbye.